All right, hello. Welcome back. A little scatterbrained. In this video, we're going to be talking about ionization. Okay, and the reason we have saved this is because this is so much easier to visualize when you are looking at Bohr diagrams. Okay, so before we get too far, you need the worksheet that you worked on where you drew Bohr diagrams for all of the isotopes that you were given for periods 2 and 3. Okay, so dig that out. Hopefully you didn't throw it away because you were told to keep it, because we're going to be using those as visuals to help you understand kind of why things are ionizing the way they are, how you can tell for sure, stuff like that. Okay, so I'm going to assume at this point you have those out and you're ready to go. So, ionization is just straight up the process of actually turning into an ion. Okay, we have been assuming so far that every atom is neutral, and that is very much not the case. If every atom was neutral, then molecules couldn't exist, really. And you wouldn't exist either. Nothing would exist other than probably hydrogen. Well, that's a bit of an exaggeration, but we'll save that. Ionization is one of the predominant methods by which compounds form, that molecules come together. So, ionization is something that you have to understand. So, what we're going to do is I'm going to have you guys ionize half of the atoms from your Bohr diagram worksheet. Okay, so I'm going to do 2 of them with you. I'm going to do lithium-8 and nitrogen-15, and I'm really just going to do this one and then have you try this one, and then we'll go through it. Then I'll go through it, well, you'll pause it and go through it. You know the drill by now. So you have to understand something about atoms when it comes to ionization. And that is that atoms want a full energy level. They want a full outer shell. But when we say a full outer shell, we don't actually mean a full outer shell. And this is one of those stupid things that would make more sense if we taught you more, but I don't think you really want to get into the details and minutiae that you have to understand to really understand what's going on here. So, we need to talk about something called valence electrons. Valence electrons are the bonding electrons. They're the electrons that actually form bonds. No electrons in an atom, other than the valence electrons, can form bonds. Okay? And this is really important because there is a limit, for reasons we're not going to get into, there is a limit to how many electrons can be valence electrons. Atoms cannot have more than 8 valence electrons. And those of you who go on to chemistry will talk about why that is. For now, you just need to know that atoms need 8 valence electrons. Okay? 8. That's the magic number when it comes to electrons. Atoms want 8 valence electrons. Okay? So they want to fill, basically, that shell. They want to acquire as many as they need to get to 8, or they want to get rid of enough to go down to the level underneath. Okay? So we're going to do an example of each. So here is lithium-8. Okay, this is one of the Bohr diagrams you should already have drawn out. Okay, so it has 3 protons, 5 neutrons. Neither of those really matter right now. What we care about is the electrons. Okay, if we look, because this atom is neutral, lithium has 3 electrons. Why does it have 3 electrons? Well, it has 3 electrons because we said it's neutral, and if it's neutral, then the number of protons and electrons has to be the same. Okay, so when this atom ionizes, what's happening is it doesn't like the fact that this electron right here is by itself. There are no other electrons in this orbital, in this energy level. It's by itself. Okay? And the atom absolutely hates that. It needs a full outer energy level. It can't get by without a full outer energy level. It wants it more than anything else. It has to get that full outer energy level. And it has two ways that it can go about getting that full outer energy level. It can either gain enough electrons to bring it up to 8, because 8 is the magic number, can gain enough to get up to 8, or it can shed or get rid of enough electrons to go down to the previous energy level. So this energy level is filled. It doesn't have 8 for reasons we're not going to worry about right now, but it is full. The first energy level can only hold 2. So if this lithium atom gets rid of this electron, then it will have a full outer energy level. As an alternative, it can gain 7 electrons. It can go out and find 7 other electrons somewhere to add to its collection, and now it has that full... Yeah, I got 8. Okay. It has that full outer energy level. It has the number of valence electrons that it wants. So the question becomes, well, which is it going to do? How does it figure it out? Well, we already taught you that. What is... I'm getting ahead. What are the 4 classifications of elements? First off, go ahead, list them. Come on. Hydrogen, metals, nonmetals, and metalloids. Okay, metalloids and hydrogen, we're not going to worry too much about. I'm going to give you something to go off for those. But metals and nonmetals have rules. They have very important rules. What was the defining characteristic that makes a metal a metal? Well, it's the fact that metals can't gain electrons. They have to lose them. That's what makes a metal a metal. It has to get rid of electrons. It can't go out and find new ones. It can't collect them. It has to get rid of them. And nonmetals are the opposite. They cannot lose electrons. They have to gain them. And then metalloids can do either, and hydrogen sucks. We're not going to worry too much about hydrogen. Metalloids can do either, so there is a rule for you to use, and that is that they will take the path of least resistance. Okay, and for that reason, we're not going to mess too much with elements like, I think, silicon and germanium that are in group 14, because things get weird with them. But boron has 3 valence electrons. You can look at your Bohr diagram and see that. Boron has 3 valence electrons, but it's a metalloid. So does it gain or does it lose? How do we figure it out? Well, if it has 3 valence electrons, it wants 8. So its options are, much like the lithium atom, it can either gain 5 to get up to 8, or it could lose the 3 and go down to the energy level underneath. Well, which is easier? It's way easier to get rid of 3 than it is to come up with 5. So boron usually will lose. Not 100% of the time, but usually it will lose. Okay, and this trend extends to most of the metalloids. Again, silicon, germanium, a little weird. But for most, that's how it works out. And for the most part with metals, you can see this as well. Lithium, because it only has 1 valence electron naturally, I'm going to pause this and undo what I've done here, so I'll be back in a moment. Okay, because lithium has only 1 valence electron, it's way easier to get rid of that 1 than it is to collect 7 more. And more to the point, lithium's a metal. So obviously it's going to lose electrons. So the ionized form of lithium, you can either draw it neutral and cross out the electron that no longer matters, or you can just draw it without that outer energy level. This is also an acceptable diagram for the ionized lithium. However, there's something else you have to do, because an ion has to have a charge. Now, for a neutral atom, the charge is obviously 0. But that's not the case when an atom is not neutral. So you have to put, and you can do this like this, or you can forego this, but this is the way I always have done it. What you have to do is you have to add a little note up here of what the charge actually is. Okay? So it lost an electron. And so most of you are going, oh, lost means subtraction, therefore it's got a charge of -1. And that is wrong. Its charge is not -1. Its charge is +1 because it lost a negative particle. We can look at the atom here and figure that out. We have 3 protons and 2 electrons. Well, the ionic charge is equal to protons minus electrons. So 3 minus 2 equals +1, not -1. Okay? So basically what it comes down to is when you're gaining or losing electrons, it's the opposite of what you're doing. Okay? The charge is 1 because 1 electron left. Okay? 1 electron moved, so the charge has to be 1. But is it positive or negative? Well, you lost 1. You lost 1 negative. That negative means it's the opposite. So because you subtracted 1, the charge is positive. Now, pause this and do nitrogen. Okay, I'm going to assume you've done that. I did just realize I forgot to cross this out. That's 2 now. Okay, so nitrogen has 5 valence electrons, and it wants 8. So its 2 choices are gain 3 or lose 5. Well, gaining 3 is a lot easier than getting rid of 5. And nitrogen just so happens to also be a nonmetal, which is also a pretty good hint. It has to gain electrons because it's a nonmetal. It has to go out and gain electrons. So we are going to add, I'm going to do it in a different color, 3 electrons here. But because we have added 3 negative particles, again, the charge is not 0 anymore. It's now -3 because there are 10 electrons now and 7 protons. So this has to have a negative charge. Now, that's pretty much it for this video. I want you guys to go through and ionize the other 6 Bohr diagrams from the worksheet for this period 2. Okay, ionize the other 6 of those. Hopefully there is a key linked in Canvas so you can see if you did that right or not. If there is not, then we'll cross that bridge later, I guess. But hopefully there's a key there. So I'm going to sign off here because I've got to record a couple more videos. Have a wonderful night, and I will see y'all whenever.